Hi, this is the report video for Team Linabell of the course EE542. In this video, we will briefly report what have we done for Lab 10, which is turning your Android phone into Ubuntu Linux-based IoT. Hi, this is Dong Hao. The first thing we need to do for this lab is to install Ubuntu Touch on our phones. I am using Google Pixel 3a XL. The installation should be a little straightforward, but as you can see here for my phone model, I need to downgrade the Android version to the latest Android 9.0 release. So I proceeded with the instruction website mentioned in the dialog. According to this website, it seems that I don't need to sideload the image because I am not using Pixel 6, but I still did this because I would like to know how this works. To sideload the image, first we need to go to this website to download the image for my phone model, which is this model. Then turn on the developer mode, turn on the OEM unlocking, and also turn on the USB debugging. Then connect the phone to the laptop and just proceed with the first command here. First command in here to reboot into the recovery mode. After that, on the phone side, we need to select here the apply update from ADB option. Then the phone will wait for the command from the computer. Then we execute the second command to make sure that the device can be recognized. And then the third command here, we execute this command to sideload the image to the phone. After that, as you can see in the picture here, the image is successfully sideloaded. Then we reboot the phone and we can receive some updates because of the newly sideloaded image. The next thing I need to do is to downgrade the Android version to 9.0. To do that, first I need to download the OEM driver of the Dell computer because I am using a Dell computer, and install the driver. Then I need to follow these commands here to unlock the bootloader and install the image. Then relock the bootloader. The pictures on the right side is showing that we need to confirm on the phone that we want to lock and relock the bootloader. Then the rightmost picture is showing that the Android version has been changed to Android 9 and the build number is exact as the installation program required. Finally, I can install the Ubuntu Touch. It turns out that this is relatively easy. Just hit the next button and make the right selection here. Then the installation program will do all the labor of the installation. One thing I need to mention is that we need to manually reboot the phone into the recovery mode when prompted, as the third picture shows here. Then just wait for the installation to finish. The phone will reboot and the Ubuntu Touch system will review. Connecting to a phone by SSH via a Wi-Fi is done in this way. Just follow the instruction mentioned on the website here. Basically, we need to configure and start the SSH service on the phone, then just use the normal SSH command to connect to the phone in a terminal on the computer.
Now I'm going to show you the task 2, how to disable graphic user interface. And this command is used to turn off the green screen. And as you can see, the screen is shut down, but we can still record and play the audio. Let's play our audio. Record on audio. 1 2 3 1 2 3 1 2 3. And I'm going to play that. 1 2 3 1 2 3. This is the task. This is the task 2.
We reduce the clock frequency by changing the content of some files. To check the current frequency of the cores, we can use the command in the left side. Since we are going to change the files of the Ubuntu Touch, which is a read-only file system, we need to enable the write permission by the command in the second picture. Then by changing the type of the CPU governor, we need to first check the available types of the governor by the command in the third picture. Next, we change the governor of all 8 cores on my phone to the power save governor. The power save governor set the frequency of the core to the value set in the scaling main freq file. After this, I noticed that there are 2 CPU frequencies on my phone. Each frequency is controlling different cores as shown in the second picture on the left. Each policy has certain available frequencies that we can use. In my case, the lowest is 30,000. So I changed the frequency to the 30,000 in the last picture. Here, as you can see in the first picture, the frequency of the first 6 cores has been changed to the frequency that we set. Just do the same steps, we can change the frequency of all the cores to the lowest possible. Recording the audio seems a little easy. The command on my screen will record the audio using microphone in the phone for 5 seconds. Let me show you. Hello, 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 hello. Then we will use the airplay command to play the audio. Hello, 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 hello. As you can hear, the audio has been recorded. It turns out that sending an SMS message is also not hard. In my case, my carrier is Mint Mobile, so I need to go through the instructions shown on the left to set up the APN. After that, this command will send the SMS message to some phone number mentioned in here. The command on my screen will send the SMS message to the phone on the right. So after I hitting this command, it said the message has been sent. And as you can see on the screen in the right phone, the message has been delivered.
Hi everyone, I am Boyang and let me show you the step 6 of our lab. You can see that this is the source codes of our step 6, and what it does is it read the WAV files from our local storage. It detects if there is a loud sound in these WAV files, and then it do the next step. So the first step is that we read the WAV files to our memory. I use an open source library from GitHub, and its name is audiophile.h. And after we read the WAV files to our memory, we have to set a threshold value, and we count how many sample points in these WAV files exceed this threshold value. And if the whole number of the so-called loud sample points, then we can say that there is a loud sound in these WAV files. Or if there is no sample point exceed this threshold value, we can say that there is no loud sound in this WAV file, and we can skip this whole program. And then we push this source code file to our phone, and we run this source code in the shell. You can see that what we do in this shell is that we first compile this source codes to a binary file, and then we run in a loop. And in this loop, the first thing is that we record the surrounding sound of our phone, and we set the recording time. The recording duration is 3 seconds, and after 3 seconds recording, we save the recording files to the WAV files named temp.wav. And then we execute our program, and we take the WAV files and the threshold value into the program, and we determine if there is a loud sound in these WAV files. And if there is a loud sound, it will send the message to our phone. And if there is no loud sound, we just remove the temp WAV files, and we do the whole thing again, and we run all the thing in the loop. So let me show you how does it look like when the whole program is running in this step 6. Hi everyone, I am Boyang Xiao, and now I will show you how our sound detector works. So let's run our shell on the terminal, and it's running now. And you can see the program will first record the sound of the environment around the phone, and then if we talk just like normal people, the phone will not send the text. But if we clap our hand like real loud, and you can see that the phone detected a loud sound, and it will send a message to my phone, and the message is shown here. Let's make some more noise. And you can see there is a second message. So this is how our program works.
For extra task, we found an application that can display sensor data. It seems that we need to develop an application using Qt to acquire sensor data, but we don't have enough time to do the experiment. This is the end of our presentation.